Hello, and thank you for joining me today. We're going to cover the seaborn box plot and when and why and how to use it. Okay, so seaborn, so SNS, we can put seaborn as SNS, the standard alias, SNS.boxplot, data equals df, and x equals our continuous variable that we'll put along the x-axis. So the way a boxplot works is this is the interquartile range, the 25th and the 75th quartile. The median is right in the middle, this middle line, and the whiskers go up to 1.5 times, starting from here, 1.5 times the size of this box. This is the standard definition of an outlier. And when you look at this, really what we're doing is we're generalizing a lot. We're just saying the data goes up to this point, but we're not really showing you how and where it is. We're saying that here's the middle part of the data, but we're not really showing you the texture of how that really develops or how the middle lays. It's just here's the middle. And so we generalize it. So box plots are really good for inspecting outliers, specifically focusing on the outliers. So we've identified here the traditional definition of an outlier, 1.5 times the interquartile range. Here are our outliers. So here it allows us to focus a little bit on those. We can do not the hue argument, but if we plot a category across one of the axes, seaborn will automatically group by that category. And here we get, so we have group A, B, C, D, E, and then a continuous variable across the side. And we can really highlight now where the outliers are in each group. We can see each group has one outlier, but this A group, it doesn't really have an outlier technically, but the whole distribution is kind of shifted to the side. So we can see here, we're not able to see the texture of each one, but we can see the generality of the distribution. Generally, this one is a little bit, in a different position than the other categories. So this would be insightful and something to inspect a little bit more. Okay, if we want to add some texture to our plot, spice it up a little bit, we can add line width equals to 3. This will change the outside line of the graphics right here. I find that very valuable. I think it just looks a little bit better. One thing that I find really valuable though is the standard definition of an outlier is 1.5 times. If we want to change that, we don't want to use the standard definition, we can use WIS equals, and this would be the proportion of the interquartile range are we using as our outlier definition. So I've dropped it to 1.25, and you can see now we have some more outliers versus the 1.5 times where we didn't have that before. Okay, so this allows you to control your definition of outliers, and then again focus on your definition of outliers. Okay, thank you so much for joining me, and I will see you next time.